going to talk about the SN1 reaction now. SN1 stands for unimolecular, the 1 stands for unimolecular, N stands for nucleophilic, and S stands for substitution. In the SN2 reaction, there is no intermediate. Okay, there is no intermediate. In the SN1 reaction, there is an intermediate. Take note, this is one difference between the SN1 reaction and the SN2 reaction. SN1 has an intermediate in the reaction. SN2 reaction has no intermediate. The rate is proportional to the concentration of the alkyl halide, and racemization occurs. Okay, racemization is a concept which I will talk about later. Okay, now we are going to focus on this part of the slide over here. Now, very often when we talk about the formation of the carbocation, and you know that this is the slow step of the reaction, right? This is a slow step of the reaction. And like what the lecturer would have said, this is the slow step of the reaction because it involves bond breaking. And this equation looks weird if you read it carefully actually. How is it possible that the Rx bond will break automatically to generate the carbocation? And this is something you got to realize. There is actually a part to play by the nucleophile. If you can imagine with me, the whole Rx, the outermost shell or the outermost structure of Rx is the electron cloud. Now, if I have a nucleophile approaching, it's just approaching, they might not even be touching. Okay, the orbitals need not even overlap. If I have a nucleophile approach the Rx, the nucleophile also has an electron cloud. Now, as long as they are close enough, there will be a repulsion of the electron cloud between the nucleophile and the Rx. And when that happens, the electron cloud within the Rx over here actually gets pushed towards the halogen. Okay, now this is how it works. Okay, got to realize that there is actually a part to play by the nucleophile. And after you form the carbocation, this is the intermediate. The nucleophile can then do the normal attack because of the attraction between the negative charge and the positive charge to give the final product. Okay, another look at the mechanism. Like I said just now, the nucleophile approaches this alkyl halide. And because of the repulsion in the electron cloud, the electrons between this carbon and this I gets pushed towards the iodine, and we have the formation of a carbocation. Since this is a bond breaking step, this is going to be the rate determining step. After that, you have the nucleophile doing a nucleophilic attack on the carbocation intermediate on the positively charged carbon, and the part of the nucleophile that is doing the attack would be the lone pair of electrons or any atoms that contain the negative charge, we will use those electrons that contribute to the charge to do the attack. Okay, and in the third step, if the nucleophile was neutral, or in this case is the alcohol, a third step of deprotonation would be needed. Okay, take note of the energy diagram for the SN1 reaction. Okay, now in the SN2 reaction, we only have one peak. Okay, SN2 reaction is like this. Right? There is no valley. Right? No valley in the reaction. But over here, for the SN1 reaction, we have a valley in the energy profile diagram. Okay, and that point represents the intermediate. Okay, the intermediate. And in this case, the intermediate is the carbocation. Okay, you got to realize this. This is the difference between the SN1 reaction and the SN2 reaction in terms of energy profile. Now you can also look and understand why step 1 is the rate determining step in terms of activation energy. This is the activation energy for the first step, right? And this is the activation energy for the second step. Which one is larger? Okay, I hope you can tell me is step 1, because step 1 is obviously very much higher than step 2 over here. And in that way, we know that the whole rate of reaction is going to be determined by step 1. Okay, and the order of reactivity, when you look at the structure of the alkyl halide, is going to be opposite to SN2. So in this case, a tertiary alkyl halide would be more likely to react through an SN1 mechanism compared to a primary or just a methyl halogen derivative. Okay, and this is because, like what you learn in your alkane-alkene, if I have a carbocation, a C+, I need to have as many R groups to stabilize it via inductive effect as possible. Okay, so this is called the electron donating inductive effect. And the more stable the carbocation, the better the energy level. In terms of better, I mean the energy required to form it would be lower. Therefore, it will be likely to be formed and the reaction can be faster. Okay. Now, this diagram is very, very important. Okay, after you form the carbocation, take note of the shape of the carbocation. Take care of the shape. Take a good look at the shape. It is a trigonal planar about the central carbon. Therefore, the nucleophilic attack can either take place from the top or bottom. And in that way, right, we have two possibilities. In SN1, SN2 reaction, we only have one direction for the nucleophile to do an attack. Therefore, there is only one inversion product. But for SN1 reaction, we have two possibilities of attack for the nucleophile. Therefore, we have two possibilities for the product. It's either, in this case, the Br2 leaves from the top, the alcohol comes in from the top, we have a retention. So this is a top. Okay, now this is from the bottom, so if it's a top bottom attack from the bottom, I will have an inversion of configuration. Okay, so just remember, I will have two products. Okay, that is a key difference for SN1 versus the SN2, which we only have one product. Okay, and this is the idea of carbocation stability. So the more stable the carbocation is by inductive effect, electron donating inductive effect, the more stable it will be, and the more likely that alkyl halide is going to have a substitution reaction via the SN1 mechanism. Something which is not taught at the A level, but I think is good for you to know. In terms of an orbital diagram, this is the orbital diagram for how stabilization takes place. Simply put, it is just an overlap of the sp3 orbital of the CH3 for the vacant p orbital of the carbocation. That's all. This weak overlap is not possible if I have a hydrogen attached to this C+. Okay, I can only allow for hypoconjugation to take place if I have a sp3 hybrid orbital, because they are of similar shape and the distance is close enough for overlap to take place. The small loop over here, is what you have studied in the SN2 mechanism reaction. Is where the nucleophile can do an overlap. Okay, so this is a quick summary. The most important thing for our syllabus would be this, and this. Okay, racemization just means that there are two products. Okay, inversion at chiral carbon means there's only one product. That's all for the summary, and I will see you for tutorial next week.